Good evening, everyone, to our quarterly content training number 3 for grades 6 through 8. My name is Edgardo Carrion, and I'm one of the coordinators for secondary 6 through 8, sometimes including Algebra 1. And with me is going to be co-presenting.
Good evening, everybody. Jackie Malone here.
Thank you for joining us. This is going to be a fast session in terms of time. We have only 1 hour, so we're going to try to squeeze as much as possible of the material that we have prepared for you this evening. Hopefully, we can provide you with some insights about quarterly 3 and provide you with some ideas. And maybe if you have any wonderings, we can address them in time. Okay, so let's go ahead and start. Can you see my screen? Thank you. If you happen to be one of the SILT members that participated with us last week, let me give you this disclaimer. This is very similar, but we are going to be addressing a different activity than the one we use for SILT, okay? So if you were part of our SILT team last week, this time we're going to be addressing a different activity. So you might want to stick around just to see what that activity is all about. We're going to start off with this opening activity. This is a very good activity. Jackie will put in the chat the link for you to access an additional or alternative slide deck where you will see this one activity as well. And you can use, if you want to use your annotating tools on your screen, you can use that. So this activity is very interesting. You can do it on your own, or you can collaborate with someone else in the group. The objective is to make words of 3 or more letters. So the moment that you end up using all of the letters on this square, then you can stop and then count how many words were you able to make using all of the letters. Now, there are some restrictions on this activity. You may not use 2 consecutive letters, okay, on the same side. Let me show you one example. For instance, if I have the word peas, I cannot use the letters P and I because they are in the same side of the square. So you cannot make that word that way. The letters may repeat, but not in a consecutive way. Okay, not consecutive. And keep in mind that the last word, the last letter of the word is going to be the first letter for the following word. So if you happen to have, let's say, the word lane. So we have L, A, N, and E, right? So the letter E will be the first letter of the following words, and so on. So the objective is, let's see if you can use all of the letters and if it's possible to use the minimum number of words. Okay? So you will have about 2 minutes, maybe 3 minutes because of time. Well, we hope that you enjoyed this opening activity just to get you going. We know that it's been a long day. We're going to try this, try to make it, fun, interesting, and engaging. Let's move on. The learning objective for this session is about learning how to support learners, okay, in terms of quarter 3. So the success criteria says, I can describe how engagement strategy and concrete learning experiences impact student learning. One of the pieces that we have seen going to campuses is students either or in rows or they might be in groups, but they may not have that many opportunities to have a concrete experience or maybe an engagement way to jump into the lesson. So we're trying to promote more of these engagement strategies as we prepare for, for PDs, or we deliver a PD for SILT members. And we hope that you can get some of those pieces, the concrete experiences and the engagement strategies on this session. The 2023-2024 core values for Dallas Independent School District are 3: effective instruction, equitable access and outcomes, and excellence. So those are the 3 core values for this school year. Our target is a 360-90. For this particular session, we're going to be focusing more towards the 90%, because this is how we can get students to perform and do better in any way possible. So we're trying to aim all of our efforts towards that 90% target. Academic services, and specifically the STEM mathematics department, is all about the instruction, the delivery, and the design of these lessons, along with what Carnegie has provided to us on this year. We're trying and striving to do better quarter after quarter. I'm going to give you a minute now so you can read this slide and see what would be the way that you would answer this question. What would be your response to this question?
Edgardo, do we respond through the chat?
We're going to make this faster. Any volunteers?
Yeah, I guess all means tier 1 instruction. Carnegie has to be implemented with for all students in Dallas ISD.
Thank you, Ms. Acharya. Anybody else? Every single one of our students should get that tier 1 instruction, right? If they haven't been identified that they need, additional support, they should get the tier 1. And when we say tier 1 instruction, is Carnegie Learning, including Mathia. So do not leave Mathia out, because Mathia is part of that tier 1 instruction. Remember that Mathia it represents 40% of the instruction, and then the 60% is for you as a facilitator of your daily instruction. So Mathia, along with the lessons, that will form that 100% of the tier 1 instruction. Keep in mind that for tier 2 and tier 3, we have iReady, and that is a resource that is already accessible. Okay. When we say tier 1 resources within Carnegie Learning, keep in mind that we are talking about the assignments. We're talking about skills practice. We're talking about the use of Mathia, and absolutely ways that we can send home or maybe provide to parents if they want to be in the know. What are their child doing? What are their child learning this week or this topic? And then we can use the family and caregiver guide, which is going to be like, for the whole module, what is it that we're going to be covering in it, right? So this is another document that is for a tier 1 instruction. Here's the link for the one-pager. Here's a one-pager where you're going to see quarter 3 links for weekly lessons or IPCs. You will see the YAGs, topic overview, module overviews, and the quarterly calendars for 6 through Algebra 1. Jackie already put that on the chat, so go ahead and click on it so we can start on that. And our focus for quarter 3, keep in mind, quarter 3 will be mostly module 4 for 6 through 8, including the honors. Most of them are going to be addressing module 4. But at the beginning of quarter 3, we may have some module 3 lessons or topics still to teach, but it's mainly module 4. In this particular session, we're going to focus in this piece in 7th grade, which is analyzing populations and probabilities. For 7th grade, we have 3 topics: introduction to probability, compound probability, and drawing inferences. These are the 3 topics we're going to have in 7th grade. And we are going to be focusing on one of these topics for the activity that we have prepared for you this evening. Okay. And with this, I'm going to pass it on to Jackie so she can guide us through this next section.
Okay, so as we get into probability, keep in mind too that this is the only time students see probability in middle school. They don't see it in 6th grade. They don't see it in 8th grade. They won't see it again until geometry. And so we don't want to kind of leave this out. It is highly connected to proportionality. So that's the good part, is that we can tie it into those concepts. But take a look at the data from STAR of 23. We can see the 2 readiness standards are in green. One was not terrible at 53, but the other one, 7.6i, is at 24%. So it's quite low. But notice the 2 lowest standards that we have there in red. And what do they have in common? We can see that they're both related to simple and compound interest. So there's something there, because the other 2 standards are not terrible. There's something there that students are struggling with. So let's dive in a little bit more. Keep in mind too, I know we have a lot of people that have 7th honors, a high population of 7th honors. They will see this module in 7th honors as well at the end of the year. So even though it's coming into quarter 3 for 7th grade on level, it's going to be in 7th honors at the end of the year. Okay. So when we talk about students being engaged, what are some of the indicators? If you would take a moment and place your answers in the chat, what does student engagement look like, sound like, feel like? How do you know when students are engaged? Okay, got a few answers. Let's see how our answers are comparing to some of the research. They're talking with each other. I think I saw that in the chat. Developing skills rather than memorizing, using higher order thinking, doing something physical. So I know I saw some being active in the chat when they're communicating. So what didn't we see in the chat? Maybe that constructing knowledge, the developing skills, those are all indicators of when students are engaged. We also know that when we're using concrete experiences, that almost builds in the engagement. But even when we don't have the concrete, we need to find a way to keep them engaged, right? Because when they're off task, we know that's when things go awry. We're going to take a look at one of the lessons. This is a 7th grade lesson called Toss the Cup. It is lesson 3, and it's a 2-day lesson. The first day, they're going to be determining experimental probability by tossing the cup and predicting using a spinner. Then, as you see in day 2, they move away from the concrete and they go to the abstract using proportional reasoning. So we're going to take a look at day 1. If we start in with just proportional reasoning, we may lose them. We may lose them because they're not interested. We may lose them because they're lost and they're struggling with the computation. So let's capture them on day 1, and that engagement can propel them to day 2. So we're going to take a look at the second activity. The second activity is the spinner. But before that, we need to have background on what are students bringing to the table. This is all in the first day. They're going to be playing a game called Toss the Cup, where they're doing an experiment, explaining that is what experimental probability comes from. It comes from doing an experiment. Now, the whole gist of this is they have 3 outcomes. The cup can either land on the bottom, the top, or the side. And the whole point of doing this, when you get to the different point values, is to see, is this a fair game? If we go to the next slide, because this is just sort of background information for you before we get into it. Okay, so it's predicting, it's looking at are the outcomes equally likely. And then at the very end on the next slide, we're going to skip to the last question. The last two questions is it fair? Now, we don't want to take the learning away because tossing the cup is quite fun for the teachers as well. We know we have to do this in our class before we do this with students. And then how do we determine the exact possibility? Is it really a fair game? Because that leads to equal distribution of the sample spaces. All right, so we've done that. Now we're gonna take a look at the spinner. Now we're gonna be predicting. So now we're moving from experimental. How do we use that to predict? Okay, we're gonna use this spinner. This is a spinner that they show in Carnegie. What are the sample spaces of the spinner? Y'all go ahead and come off mute. Let's have a conversation.
Are you asking about like the star, the sun, and the smiley?
Yes, we can use the star, the sun. Those are our sample spaces because those are our possible outcomes. Okay. Can we determine the probability of each on that spinner?
Yeah, depending on how many times you use the spinner. So smiley face would be 1/3 if it's used one time.
Is it 1/3? How do we know it's 1/3 by looking at the spinner?
So you have to count the total number of sample spaces that we have.
Okay. Do we have another thought?
Since they're different sizes, it kind of throws things off.
Ah,
Interesting.
okay.
That's great.
The smiley face maybe looks like it's 1/3, but the other two, they're one is really big and one is much smaller, right? Okay. So where do we have the best chance of landing?
Star,
Why?
bigger space.
Okay.
Almost half.
Almost half. Yes. Okay. So, and kids can see this. Kids can see it's not fair, right? So we come off the tossing the cup and we move to the spinner and we see, is this spinner fair? Well, how do we predict the possibility of it, the probability? If we look at number 4, question number 4, the probability of it landing on a smiley face. I know Sataria had said 1/3. And then I'm not sure, there was a gentleman. Was that you, Mr. Wells, that said it was almost half for the star?
Yes.
And then what about the sun?
Just under 1/4, maybe 20%.
Yeah, that one's a little bit harder to tell, right? Okay, well, there we go. Okay, so we're gonna do a little bit of analysis with what did Jonah and Melanie think about this? They determined some probabilities. And I think now we have 19 of you. We're gonna go ahead and send you all to a breakout room, and it's not gonna be for very long. Okay, may I hear from somebody from room 2? Tell us what you said about Jonah and Melanie. Okay, do you mind, can you see it on the screen now? Do you mind telling us what you think?
Why they're both incorrect? Let's see.
They're both, okay. Who's
Think somebody
more-
else can say.
who's closer to probably the correctness,
Jonah,
and why?
because in the picture you can see that they're not all the same. And for Melanie, she has them all as equal, but even
Yeah.
without numbers, like the colors show that it's not the same.
Right, yes, perfect. Thank you. Okay, so how can we determine the exact probabilities? That
By
one-
doing the experiment,
Pardon?
I would say by doing the experiment.
Okay,
Mhm.
let's do it.
In my group, we talked about how Melanie was a good example because students often assume that you just divide the number of parts. And then we talked about how something we could do is ask students, if I were to give out a piece of candy based on if I land on your spinner symbol, which symbol would you want to be, to get them to start thinking about it.
Right,
I also think that coming from what they're covering now in algebra. Oh, sorry.
Taylor?
What they're covering in algebra, they may want to assign like an algebraic variable to the smallest quantity, because that's something we talked about with this past, what is it, the picture algebra unit, that you could have the smallest unit be X and then go from there. But yeah, I think if we
Yeah,
can,
if it's an unknown.
Mhm.
So let's take a look at where this is gonna go, because now you are gonna, like you said, actually doing the experiment is where we're going with this. Is so once we get kids to see the fairness part of it, and that Melanie is just assuming that it's all equal, so it's fair. Jonah recognizes it's not fair, but even though his numbers may be off, because we can see it can't be a fourth and a fourth. Those clearly were not equal, right? And so even his pi wouldn't, because its spinner is really a pi, it doesn't add up to one whole.
200%. Yeah.
Right, to 100%. So let's go on to the next slide, Edgardo. So experimental probability, because we're going to have to do an experiment and we're going to have to use the spinner. You all are going to have a moment to take a look at the spinner that you can use. And Edgardo, can you go ahead and click on the spinner and pull it up? And I think what I'll do is, while you're doing that, I'm going to put the link in the chat. And
I
if you
already did.
Okay, if you guys are able to pull it up, we can show you how to adjust it. When you first pull up, this is a virtual spinner. You can adjust the amount. It comes up with having 6 spaces, and you just want to decrease that so that you get 3 spaces. So underneath the spinner, you would click on the left arrow to get it down to 3 sections. And then if you grab that and just drag it, you can make your spinner very similar to the one that we have. It's okay if it's not perfect. Obviously we don't have the little emojis there on this virtual one, but we can see we can get this spinner pretty close. Then what you can also do, now this is not going to allow you to do the experiment part. If you put the number of spins as 50, then it'll just populate spin after spin after spin until it gets up to 50. And it'll just keep going. And if we skip to the end, it'll show us what the experiment gave us for each. But then it also gives us the theoretical, and the theoretical is going to be those exact numbers. And we can see that what we get in our experiment isn't always exactly what it should be on the theoretical. We can see it's off a little bit. Well, why is that?
Because it's a probability. So it's never going to be exact.
The nature of randomness.
The nature of randomness. We can see the theoretical is what it should be, but then there's that randomness every time you spin a spinner. We still know we're pretty close. And this is why kids, they struggle with the experimental and theoretical. Then how do we do the math for experimental? How do we do the math for theoretical? And then use those to make predictions. So on the next slide, Edgardo, can we go back to the slide deck? This is where students would record the 50. And we could, if we use that, we could just skip to the end. Well, this is just day 1, but the next day we're going to move into actual probability, proportionality, in order to make some predictions. So that was if we roll the spinner 50 times, but what if we roll the spinner 200 times? Now, students would have already had some background knowledge in scale factor. So we know that 50 times 4 would give us 200, but that's how we would use the experimental to then scale it up. Okay, if you can click, Edgardo. But that's sort of where it goes the following day. They give you the probabilities and say, okay, now we've all done the experiment. It's all random. Everybody's got their separate numbers. But now day 2, let's come back. These are the numbers we're going to use. And these are the numbers we're going to base our predictions on. Now we're getting into the abstract. So in the chat, we're going to ask you, before we move on to look at 6th and 8th grade, more so 8th grade, in the chat, will you tell us how would the experience with the cups, if we did the cups first and the spinners, those are in day 1, how does that affect student engagement even in day 2? And go ahead and hit enter whenever you get your comment ready. Real life experience, an example to refer back, real world scenario. They're going to remember that spinner and that cup, right? One, they're going to remember how much fun they had. Do you think they'll be excited when they come in the next day? Hopefully, right?
Possibly.
These are 7th graders. It'll feel more approachable. Yes. Thank you all for your participation in the chat. We're going to move a little faster, or we're going to move on so that we can also take a look at 6th and 8th grade. And with that, I'm going to pass it back to Edgardo.
So for 6 and 8, so we address 7 for the fact that 7th grade is like the misbehaved child that it always gets in trouble. They do things, behind your back, and they might do something and then they don't take ownership. So 7th grade is like that, the problem child. And now we're going to pass on to the 6 and 8. Let's see what is the alignment that you can perceive for what is upcoming in module 4 for 6th and 8th grade. And I'll give you like 30 seconds. If you can put on the chat, go ahead and do that, please. So what is that alignment that you see between 6th grade and 8th grade? Equation and inequalities, definitely. We have to get our students in 6th grade, strong and solid with expressions and equations so they can move on to inequalities and then getting to solve system of equations in 8th grade, right? So yes, definitely. 6th grade and 8th grade on quarter 3, they have a very interesting set of standards. Now, these standards are as follows. So we will talk about 610A for 6th grade and 8.8C for 8th grade. Now, you won't see 711A at this point, nor in 7th grade for quarter 3. Okay, if you teach 7th grade, you may remember that 711A, it's a standard that was not there until we got to module 2. It was part of module 2 at some point, and then it went away. Okay, so let's have that in mind. What comes to your mind when you see these scores and when you see these 3 standards? What comes to your mind?
So when I see 8.8C, I feel like that standard is low because that's not always a standard that can be solved by the calculator. The question sometimes asks, what is the next step? And so if a kid can't solve an equation by hand, then they're unable to tell you what the next step is.
Absolutely. That's you hit the nail right on the head. Thank you, Jennifer. Thank you, Ms. Williams. Definitely. Yes, I totally agree. What else stands out on these 3 standards? All 3 are talking or expecting to have for students to have opportunities to model and solve. All of those 3, all of the 3 standards are expecting to prepare students to be able to model or to understand a model and then being able to solve. Okay, all 3 of them. Keep that in mind. Is not going straight to the abstract, is guiding them through the process of concrete, pictorial, and abstract. That process is there for a reason. We have to provide our students with opportunities, maybe not for all, but definitely every student will benefit from having an opportunity to go through the concrete, pictorial, and abstract approach. Now take a look at those scores. You know, we have 58% for 6th, 31% for 7th grade, and then 32%. You know, those scores started decreasing and decreasing. What might have been the root cause for this? What do you think might have caused this drop in the scores? Other than they have to work it out.
More than
Well-
one step.
More than one step, yes.
And all of these skills are loaded skills. So there's multiple things that they have to do, not just solving an equation, but when you add in the geometric concepts, that's a whole other ball game. Like we gotta factor in that they have to learn as well.
Definitely, yes, absolutely. Now keep in mind, 7th grade, you know, the 7-11, that was part of the 7 honors on module 2. Now, this standard was covered in 6 honors. Okay, last year it was part of the 6 honors. But if by any reason you had a chance or you had a 6 honors teacher that concentrated specifically on the 6th grade standards, because that's what they're going to be testing on. 6 honors, they're going to be testing on 6th grade standard, not 7. So I will omit my 7th grade standards and concentrate on the 6th grade, because that's what the STAR will be covering. Then we are neglecting 7-11A. So they will get in the mix, and no doubt they're going to be suffering once they get to 8, definitely when they get to 8. So let's move on to what is for 6th and 8th grade. Now, 6th grade, you have on your participant slide deck, if you go down to slide 15, you will see how the lesson for 6th grade, how that lesson develops utilizing a concrete element, which is the algebra tiles. For many of our teachers in Dallas ISD teaching 6th grade, 7, or maybe 8, using algebra tiles is kind of I would like to stay away from using manipulatives. That kind of mindset we have come across several times. Now, maybe I do see why might a teacher step away from using or providing manipulatives for students when it comes to solving equations. You know, algebra tiles can be a good and strong, how do you call it, a crutcher, but you have to remove that crutcher eventually, right? You have to remove and you have to push the student to start walking on its own without the use of the manipulative. Of course, if that student, it's what it needs, you know, let's provide it, you know, until you think it is that time when you need to remove that tool for them to understand. So that's what 6th grade, they're going to be utilizing models, and algebra tiles will be part of the EOT, and it will be part of the STAR. So let's focus on the 8th, and I'm going to try to pull my, okay, can you see it now?
Yes.
Okay, so here's the lesson for 6th grade. So the lesson for 6th grade involves the solving, first of all, represent expressions using algebra tiles. So you take them to represent expressions using algebra tiles. That is 6th grade. Eventually, you will move to using the algebra tiles to solve equations, okay? And this is part of the EOT. You will see some of those items using models. So they need to be familiar what is this representation I have in front of me, right? They need to be familiar with the key, how to read the key. If they see a gray box or a white box, you know, if you have a rectangle, gray or white, what it represents. So that's what you will see on the EOT. Now, 7th grade, you will see models, and you can see here from 2023, 2022, and 2018. On STAR, on these 3 years, they had algebra tiles, they have a scale, they had something that looks like algebra tiles, but they use triangles. So students need to be prepared seeing any type of model and be able to work with it. Okay, so that is,
Dario?
yes.
Can I also interject that they will probably see other models? It's not just algebra tiles or even just the triangles, because they would see bar models and also doubled number lines when they come to equations, which is fascinating and it works great. But it may be something we're not comfortable with because we've never solved equations using a double number line. But it has
So-
it in Carnegie and it's great.
So in terms of what is 8th grade doing then? So 8th grade, I'm just going to go through this activity here where you have two students solving an equation with variables on both sides of the equal sign, and they're solving it. So both two students solving an equation. And then we're going to compare the way they solve the equation. So we have Teddy and we have Topher. So they solve the equation. They both end up getting to the right answer, but they had different approaches. So here's a question that we need to address. What if I have a struggler? If I have a student that is really having a hard time solving an equation of this nature? As you can see, Carnegie is not providing the models on this activity. We talked to Carnegie saying, where is the models? Where are they? Where can we find them? They need them, you know, because not every student is on level. Some of our students may need that that crutcher, right? That tool, which is the algebra tiles. Carnegie came back and informed us saying, algebra tiles, double number line, any other tool is being exposed and used in Mathia. Mathia is the way Carnegie is providing students with the experience of getting familiar with how the algebra tiles work, how the double number line works, and how to solve an equation with variables on both sides. So Mathia is the tool that Carnegie has for our students to be familiar with the models. But if you still have students that are struggling, feel free to bring it in, you know, just make copies, or if you have actual algebra tiles, give it to those students that that may need that extra push. Okay, in this case, both students, you know, they solved it correctly, but one is more efficient than the other. It's about the efficiency on solving the equation. Of course, when it comes to an assessment, time is a factor that we have to consider. Who can solve the problem faster? And not just correct, but faster, more efficient. Here's the EOT. The EOT has no models, but STAR 2023 8th grade does have, or did have, one item in 2023 with models. And then 2016 had another item with models as well. I couldn't find one for 2022 in 8th, nor 21 or 20. So all the way to 2016. So let's try to push our students to be efficient. What is the best way to approach solving equations and inequalities? What is the best way? What is the most efficient way to get to a correct answer? So to close this up, you know, how do the concrete and engagement experiences, bottom line, make an impact on our students? We had a chance to see that with the probability activity in 7th, and then 6th grade using algebra tiles, not 8, but we can transfer that. You know, what would be a good response for this final reflection. Yes, increased curiosity, definitely. At least they might want to have that opportunity to say, well, I kind of like that, or it was interesting, the cups activity with probability, you know, why wasn't fair? Why is not fair? Well, maybe the shape of the cup, the way the force, the way you flip it, you know, how strong you spin the spinner, you know, things like that. You know, it might be a good opportunity for a good conversation.